So welcome to this pre-recording of lecture 8 of an introductory course to supercomputing. So the title of today is Hands-on Supercomputing, and today I hope to explain a little bit the practical aspects on supercomputing. So I will distinguish two different kinds. So there is still the interactive kinds where we have a personal computer for us, a fast workstation, and we also have access to a real supercomputer, the UIC supercomputer, and I will also indicate how to use that environment. Okay, so we will use a computer called Pascal, named after the NVIDIA GPU that we will use later. So it is a fast workstation with many cores. So in this part of the course we do message passing. So in a way, message passing is not the right technology for multi-core. However, it can still be very useful to experiment with this and still give a lot of speed up. So here are the characteristics of this computer. So I have a window sitting ready, so I can actually do it if my network is collaborating with me. So I'm doing this, by the way, in a PowerShell on Windows. So here will be using another login account. I will be using the MCS572 guest, and I practice this. And here you see that I am connected. Now the important issue is here, so I practiced this earlier, and if I can go back to my slides, the thing that goes wrong already here, of course, if you do not have an account, but there is this VPN network that is necessary if you're off campus, and you will also need a smartphone because otherwise the two-factor authentication will not work. I have given you a password, and please change this. So with passwd, so it's, by the way, good to change passwords very regularly. Our university each year forces us to require to change the passwords. So I said that this is a fast processor, so let me indicate how you can check this. So you can type more CPU info, and this shows that there are 22 CPU cores there. So perhaps let me move this up. So you see the 22 CPU cores, and it shows also the type of CPU. Shows how many siblings there are. So actually it is a 44 core machine, but with hyperthreading it works best when you at maximum speed, when you would launch 88 MPI jobs. Okay, so that's one thing that we can try. So then there is the information about the memory. So I can so let me scroll down here a little bit. So the machine has a lot of memory available, so I can ask for the available memory, and here you see that the total memory is more than 256 gigabyte. So often using a fast workstation, is because you have more, is advantageous because you have much more memory available. In particular with Python, this is an asset. This is often not a luxury. All right, so I mentioned that we would be using this computer for GPU computing, and let me indicate what this computer has, so I can type in this information. So so I forgot the part now, but you can see that this is CUDA. So there are the samples that are there. So there is a lot of code that is pre-compiled. So I'm going to the utilities and then the device query, and I can launch the device query. This is pre-compiled. Perhaps this went scroll down a little bit too fast, but here you see that there are actually two GPUs available. So here you see the characteristics for this GPU, and the exciting thing is here the large number of available cores that we have available. So 3,584 CUDA cores that are available. So this will come in a later stage of the course, but this is why we are also going to use Pascal. All right, so a little bit of Unix. You're running this in so I'm actually now in a folder where I cannot write. So at least I can write if I'm super user there, but this is my guest account. So going back to the guest account, I do CD and then the tilde, and that will show my account. So I have been practicing a little bit. There is already something there, but actually, to be fair, for the demonstration, I will remove everything. So if you first log into Pascal, it will be an empty directory if you ask for the listing. Okay, so let me swap back the slides. So the slides give somehow the structure for this presentation. Okay, so MPI for Pi. You can use secure copies. I use secure shell to log in. There is also an editor available. So there is the VI that I tend to use. There are also other editors available, but you can use your own editor and do a secure copy. So what I will do here, I will use the wget to get the programs from the course website here. So the first program is the hello world, and I will start with the MPI for Pi. Okay, so I was mixing up the SCP syntax with the wget. So if you do SCP, the second argument needs to be a dot. So you go from your source to your destination, and the destination is the current directory. Perhaps I will illustrate that to how you can copy, do a secure copy. But it worked, so a successful wget will give you the code. So directory listing, you can see it. It is 3.py because you have to type Python 3. So it's still actually an old version of Python 3. But it will work. So let me illustrate right away how you can execute it. So it's MPI exec. Let me use 4 processors. I have to specify Python 3 and then MPI for Pi hello world. And something went wrong because I forgot the 3. Here you go. Okay, so with the arrows up, I can show what I have done thus far. I did the wget, but don't do the py. Perhaps I can illustrate. I will illustrate the secure copy when I do my next demonstration. So I did the wget. I did the listing, so to check whether it was there. And then I did the MPI exec with the tree. And sometimes don't forget the Python tree there as well. So this is a three-step procedure. And let me do it again. And here you see that everything works. Doesn't always work from the first time, but here it did. So let me go back to the slides. So there are two sites available. So you can do it always twice, but there is the departmental website and then there is my UIC website. I tend to maintain them both. We have three official languages in this course. I started with Python, but second official language is Pascal. Is Julia. So Julia is already installed, but Julia, you have to change something to your environment. So let me go back to the terminal here. So if you type more, so more is a good utility to see the content of the file. There you see that in my .bashrc, I placed the path to where the Julia interpreter, the Julia system can be found. So I also placed in there the second export path indicates where the MPI exec JL is. Okay, let me get the code. The hello world from Julia. I will illustrate the secure copy. So I will copy from my website. So it's if you download from a website, it's not, and you cannot do this because you do not have my. But assume that the part of that what I'm typing in now is your net ID, then the name of the computer, and then the folder where everything is. So on the website, on the web server, so there is the MPI hello world.gl, and now I need to specify the dot. Okay, so I haven't done this too much. And if I type in the correct password, so it needs to think about this a little bit, but you see that it was successful. So I have my hello world, my Julia program there. So I did this with a secure copy. So the secure copy works from a remote machine to your current folder, but you can also do a secure copy of any file to any remote machine using the same syntax. So you have to modify your .bashrc. Then you can just type in Julia, and you see. And the other thing that you need to do is that you need to do using MPI. Here I practiced this already, or I'm sorry, you need to do import pkg and then pkg.install MPI. So I will not do this here, but the slides have these instructions. So this is just to check that your installation works. So before you start running some code, the same with the MPI exec. So I can do it wrong without the JL extension, but actually it's better if I do it correctly. So don't forget the Julia. Sometimes one thinks about the name of the executable of the program first, and one forgets the Julia. And then you see here, this is the hello world. So this shows that MPI is functioning correctly. We know this already, but also the Julia wrappers to the message passing interface, they work correctly. Okay, so that is the Julia interface. So let me now flip back to the slides. So this explains, okay, so I said something wrong already. It's good that I double check this. So it's not PKG install, but it is PKG add. So this is the add here that you need to do. So this is a 3-steps process. So in between there can be a lot of things go wrong. If you have any questions, contact me. So for Julia, you have to, I will repeat this again because also on Extreme, on the UIC supercomputer, you will have to go through the same steps if you want to use Julia. Okay, so then just like with the MPI 4Pi, you have to get the Julia program from anywhere, or you could essentially also start typing in an editor on Pascal. Okay, last and certainly not least, for performance, there is always C and C++. So with C++, there is an extra step you have to compile. So let me practice this. So let me go back to the, let me clear this. So let's start from the beginning. So I will do the wget from the course website. MPI hello world.c. So this all went well. So if I do my listing now, you see the MPI hello world.c. So the MPI.cc is already installed. You can always check this with the which command. So which MPI.cc says where it is. So MPI.cc minus the direction of the output to hello, MPI hello world.c. And then I can do MPI exec hello. And here you see the hello world. Okay, that's it, interactive supercomputing. Any program that we have covered so far can now run in this way. Some of the other useful features are the redirection of the output. So if I want to save everything to file, then I can redirect the output. So this is how you actually make a program that sends everything to screen. It sends everything to a file with the simple redirection. Another useful command is time. So time will give me the wall clock time. Real, so this is typically the most important time, because you see that the user time is actually more than twice or close to 4 times, because I was using 4 processors. The system time here gives somehow the overhead of the startup. So the doing the hello world actually takes a lot of system time relative to the total wall clock time. Now the wall clock time will fluctuate, so there is the W. So here you see the machine is actually sleeping almost. I have still some at my office computer. Since this is my office computer, I'm still logged in there. But you see that the load average is very, very. So if for the computer projects you really want to do some timing, it might be good to check, certainly if you're going to use a lot of resources, it may be useful to check what is the load average. Another very useful command is top. Top actually says what are the most time-consuming processes. And you see that actually the top that I'm running now is fairly high on top. So this computer is currently not doing much. In that sense, computers resemble more and more our brains. Most of the time they are idle. Okay, good. So that is the interactive part. So this went fine. Everything was collaborating. So and I'm 20 minutes in. Here are the points that I ended with. So with the redirection of the output, what normally goes to screen then goes to file, and the wall clock time. Okay, let's now go to extreme. Acer has a very good website, so that would be, if you need general information, that would be the place where you can go for the 6 steps. So the 6 steps here have the first step actually is already done for us. So I'm going to demonstrate the other steps. Okay, so I can do this from Pascal still, but that is something that I wouldn't recommend. So it's better to log out here and do this not through Pascal. Although again, also here, the 2-step authentication may happen. So that's a good point to check. So how do we log in? So I log in with my NetID, and I have 3 choices: login 1, login 2, and login 3. .extreme .acer.uic.edu. So that is the whole command. Yes, I'm sure I want to connect. Then I type in my NetID, and then this is where a smartphone is necessary. So with the setup, with the 2-factor authentication that you probably did already when you press any key, and here you see that I'm logged into Extreme. So I practiced this before, so there is some information there. Perhaps I should not be so careless here and delete everything. For practical purposes, the getting of the files from the website to here is just the same. So we have our 3 languages. So I will save C again for last and start with the Python. Now there is an important difference here. One needs to load a module. So module load Anaconda. Perhaps I should probably say where we are. So I'm in my home directory, but there is also a folder classes where we have also our folders. And now let me see. I also have folders there, and there is the common folder. So in this common folder I placed Julia. That's also the location where you have to change your path. But there is the Conda environment that was already installed. Now, in order to start using the MPI for Pi, you have to do a module load. So module load Anaconda 3, and then I have to activate the module. So I have to type activate the location. So that's also on the slides. I'm actually going back and forth. Okay, so when this is successful, when you type Python 3, you see we have an Anaconda version. And when I do MPI for Pi, it is not there because I practiced this on an other node. So this is in some sense very good. So I first did this on the login too. So what I actually do need to do, I need to do conda install MPI for Pi. At least this is what I was remembering to do. So I have to check. So I practiced this on login node. Yes, the conda install MPI for Pi should work, except that it seems to hang now. That is somehow disappointing, so let me go out there and go to login node 2, because this is where I practiced it. Okay, we have to go through the two-factor authentication again. And there we go. Perhaps the activate I've done wrong and it didn't give any. I see, yes. So it was source activate. That was my mistake. Source activate conda. Okay, so yes. The conda install was actually not necessary. So what I actually want to indicate, if we have the latest or one of the later versions, I think Python is 3.11 now, but it is still a very recent version, I can then check the installation for MPI for Pi. Okay, so now I can execute. So actually the interactive nodes are not for parallel runs. So what I'm doing here is just checking whether the environment works. So do not run your Python code, your actual code here. So this is just the hello world, and I think it's the hello world 3. So here we go. Okay, so in some sense this is a clean start. So if you want to use MPI for Pi, you do the module load, the source activate, and then you can do the MPI exec. So it's a 3-step process. So let me shift back to the slides, so which have the clean preparation as it should have gone. So these are the steps. So also here you can check how busy these nodes are. So these are interactive nodes to launch jobs essentially. So you can see if the nodes are busy, you may want to pick another node. So this is the screenshot here. Okay, using MPICC. Let me keep this for last. So let me talk about first the Julia environment on Extreme. So you have to edit your .bashrc file as well. So I did this. So it's a three-step process, just like on Pascal, except that now the content, what you have to change is a little bit different. This will, when all these steps are executed correctly, then you can run the MPI exec. So let me demonstrate this. So I have already the MPI hello world on there. So I'm doing the MPI exec.jl minus n3 Julia. Or let me first illustrate. There is again the Julia environment. You see it is not found, which is a little bit disconcerting. So I may have to source this explicitly. Okay, so this may have happened because I was working in the Conda environment. So by doing the source, then explicitly sourcing my .bashrc file, I make sure that the path is set correctly. So if you have adjusted the .bashrc file, either log out, log in, that will typically or should execute the .bashrc file. Otherwise, you can explicitly source it. Okay, so we have Julia. And also here you may have to do the import, or you should do the import pkg and then the pkg at MPI. So that will download the MPI environment, the wrappers, onto your environment. So I will not do this here. So I did this already. So also checking that this is working correctly, you just do using MPI, and normally you should not see any other messages than what we've seen now. Okay, my path is set correctly. And then I can execute with 4 nodes. I can execute the MPI hello world. And you see everything went well. So we have the hello world that executed in BioJulia program. Okay, so in transitioning now to the computation via batch scripts, let me go to the C compilation. So C is still one of the official languages, and perhaps for performance, still kind of the default what one should use. So the thing is that what we are going to do now is that I'm going to demonstrate. So you may have wondered already, what is this module? So you can check the available modules by typing available module avail. So why is that important? Because there are many MPI implementations, and you can see what everything is available. So we will be using the Open MPI environment. So let me actually start from scratch again. So let me do the login node 3. So the network is working well. So this is our third and certainly not last language. So I have now C. So I will do module load open MPI. And after this command, I can see that indeed the MPI CC will be using the Open MPI implementation with GCC 11. Okay, I can check whether I can build my executable. So this is the MPI hello world.c, and then I can run it with MPI exec for nodes and hello. So the compilation step is successful, and again the error messages might be because that I should probably not have done this, but still it works. So here you see that I can compile and run MPI programs. Okay, so let me go to the slides to summarize. So here the MPI CC, it's a 3-step process. You have to select the right module, OpenMPI for our case. You do have to compile, and that is also necessary when we are going to run this with the submit scripts. But just for testing purposes, just like a hello world here, we do the MPI exec. Okay, so I still have 10 minutes left, which should suffice to now explain how you should compute on a real supercomputer. So we do not do interactive supercomputing now. We write scripts that are submitted for execution. And it's not that complicated. So here is a self-contained hello world. So we can execute the hello world by the definition of this script. So I will explain line for line what it is. But let me demonstrate how this works. So I practiced this before. So there is the PBS file. There are also the hello is there, and they see that there are many outputs there. So I will actually remove all the hello.outputs. Okay, so I have the test hello script here. So I will run it. So this is a very modest script. So I'm certainly no more than 1 gigabyte, no more than 5 minutes, and I will request 5 nodes. QBS minus little l, nodes equal to 8, and the name of the test script is test hello.pbs. I did it already wrong. So I forgot the, now there it is, Q sub minus L. So here is what I'm looking at now. So Q sub minus L nodes equals to 8. So I was too much in a hurry. Q sub minus L. Okay, so I can check my email now, but I can also check the .o. So there is not a .o there. Now there is a .o. So this .o it gives us the output, and it also gives us the wall clock time, so 2 seconds wall clock time. Also the amount of memory that is used. So it ran definitely under a minute. So 5 minutes and 1 gigabyte was still too generous. So you can be optimistic, but I think that jobs that require too much memory, too much wall time, will simply never get started. Okay, so that's essentially it. So let me summarize. So everything should be self-contained on the slides. So this is the test hello.pbs file. So that is the content. So it starts with indicating what is your shell. By default, we are using the Bourne shell, but if you want a C shell, that is possible as well. So we indicate the resources that we want. The queue here, we have an educational account, so the queue is always fixed for us. The number of nodes and the number of cores per, I think we might have 120 cores in total available to us, but I'm not entirely sure. So Extreme has 3,000 cores, more than 3,000 cores, but I also do not think that you should request 3,000 cores. Then there are these other lines. So for our purposes, getting all the output in one single file is convenient. And here you see that what we wrote to file, what we wrote to screen actually comes in the output file. So we don't even need to do any redirection. There are the email messages. So I will now have seen email messages at the beginning, at the end. And if you do things wrong, if it aborts, then you also will receive an email message. So you have to specify, if you want email, your net ID. You have to specify the name of the program. The name of the program is hello, and where the directory is, where the program is. And then last and certainly not least, there is the q sub -l command. And you must specify the number of nodes at the command line as well. So what is then interesting is the show queue, so you can see how many jobs that there are in the queue, so how much the supercomputer is occupied. You could also check your job. So when I submitted, I received a confirmation. I think the job number is what was appended to. So when I did the Q sub, you see the 1033733, and that is also the number that is added to the .o file. So that should be your job number. So that also allows you to request the status of your job. So this is very useful if you have long jobs. Here actually the job only took 2 seconds and it got immediately executed. Okay, so that is then the pre-recording. I hope this was useful. These slides will be posted. And at this point in the course, so this is lecture 8 already, we have seen the most useful MPI command. We have seen dynamic and static load balancing. So we are already able to write useful distributed memory parallel programs. Thank you for watching and see you next time.